Section 4.2, Graphs of Exponential Functions. Before we begin, I want to remind you how exponents to a negative power work. So say we have a raised to the negative exponent n. We do not work with negative exponents. So if we wish to make it positive, we would write it as 1 over a to the n. Vice versa, if we had 1 over a raised to the negative n, now we see our negatives in the denominator. So we move it up to make a to the nth power. Now I have a positive exponent. So if I have, for example, 1/2 raised to the negative 2, to make it positive, I would flip the inside. So I would have 2 over 1. Now I can square. Okay, so to remind you about your negative exponent rule. Okay, let's continue with 4.1. So let's first show off with these two examples. First, we want to graph f of x equals 2 to the x power. And we kind of have had a quick introduction about exponential functions in 4.1. So like anything that's new to us, to graph it, we can always make a chart. So we want some positive and negative values for x. So let's try -2, -1, 0, 1, and 2. Let's give ourselves some space for our work so we can produce our answer y. Okay, if we let x be -2, I'm left with 2 raised to -2 power. So I need to make that 1 over 2 squared, which is just 1/4. So I have the point -1, -2, and 1/4. I have -1, 2 raised to -1. Well, I need to make that negative positive. So I make 1 over 2 to the first power, which is just 1/2. 2 to the 0 power, we get 1. 2 to the first power, we get 2. And 2 squared, we get 4. So we have these points. We have the point -2 and 1/4, -1 and 1/2, 0 and 1, 1 and 2, and 2 and 4. And we have an image of what we just found, right? We have this graph. I included the graph so we wouldn't have to graph it. You connect all these points and you see that our exponential function kind of makes like an L shape. And we see that no matter how many negatives we pick, we go to -4, -5, and so on, we're just like getting a fraction that gets closer and closer to 0 but never crosses it. Okay, let's do another one. Let's graph f of x equals -1/2 raised to, no, just 1/2 raised to x. Okay, so let's go ahead and do our chart. We want some negative values and some positive. Give ourselves some space for our work. Okay, so 1/2 raised to -1 power. Negative in the exponent is to be positive. To make it positive, we switch the inside, the reciprocal. So we get 2. And I don't know why these are actually supposed to be switched, right? But that's okay. So we have 1/2 raised to -2. We have 2 over 1 raised to the second power, we get 4. 1/2 to the 0 power is 1. And 1/2 by itself is just 1/2. So we can actually go ahead and plot these points. So I have -1 and 2, -2 and 4, 0 and 1, and 1.5. And again, I have the graph for you right here. So we see very similar graph. we see as we get bigger and bigger numbers, it's going to get closer to 0 but never cross. So take a moment to notice how these two functions are different and how they're the same. So we see how that base of 2 and the base of 1/2 play a role as to how our function is going to look like. Characteristics of the graph of the parent function. F of x equals bx. Okay, so our characteristics are as follows. An exponential function of the form f of x equals b to the x, with b greater than 0 and b not being equal to 1, has these characteristics. First, it's a one-to-one function. It has a horizontal asymptote at y equals 0, so that's the sign right here that never crosses. It gets closer and closer, but never quite crosses. Its domain is all real numbers. Its range, it's its horizontal asymptote end on. So in this case, 0 to infinity. It has an x-intercept of none. It doesn't cross my x-axis. A y-intercept of 1. If my b is greater than 1, it's increasing, like that 2 to the x power. If b is less than 1, it's decreasing, like that 1/2 raised to the x power in our examples. And we have a picture of those two images in our definition. All right, so what are my tips for graphing an exponential function? First, you want to label your horizontal asymptote. That will help you determine where you're going to stop. Second, you really need 2 points. It has an L shape. It can only be one of these, an L like this, an L like that, or it can be reflected over the x-axis, so it can look an L like this or an L like that. So once you have your horizontal asymptote lined up, you can pick 2 points and see what kind of L you're going to work. You can use more points, of course. I think 2 should give you an idea of what you're doing. Now, with any function, we can always identify shifts. So transformations on an exponential function. For any constants c and d, the definition f of x equals b raised to the x plus c plus d shifts the parent function f of x equals b of x. Vertically, d units is the same direction of the sign d. So you see this d here? If you have a number being added to the side or subtracted to the side, that's your shifting vertically. And it also affects your horizontal asymptote, which is always y equals b. Next, horizontally c units, the opposite direction of the c sign. So you see the c right here in the exponent's place. That will determine your horizontal asymptote. No, your horizontal shift. If it's plus c, move to the left. If it's a minus c, you move to the right. And your range is always your horizontal asymptote. And if it's going up, it's infinity. If it's going down, it's negative. And your domain stays all real numbers. So let's do this example. We have 2 raised to the x plus 1 minus 3. So we can graph using shifts if you'd like, or you can do a chart. I'll show you both. So using our shifts, we know that our graph is going to be moved to the left 1 unit, and a minus 3 means that we're going to move down 3 units. Also, we have a horizontal asymptote, at y equals negative 3. Now we already graphed the line f of x equals 2 raised to the x. So what we can do is take our first function and take each point and move it. What should we say? We said to the left 1 and down 3. So we can take each point and move it to the left 1 and down 3. To the left 1 and down 3. As so. Or you can do your own chart for this problem, which is, I think, what I would do. So we have x values. We have, let's do -2, -1, 0, 1, and 2. Alright, so we have our problem here. Let's put in that value in for x. So that we have 2 raised to the -2 plus 1 minus 3. Okay, so I have 2. My exponent is now -1. So that I have 1/2 minus 3. That gives us -2 1/2. 2 raised to the -1 plus 1 minus 3. We're left with 2 raised to the 0 power minus 3, which is 1 minus 3, -2. 2 raised to the 0 plus 1 minus 3. We get 2 to the first plus 3. We get 5. And lastly, we'll do one more. 2 raised to the 1 plus 1 minus 3. We get 2 squared plus 3. You get 4 plus 3. We get 7. Let's go ahead and plot our points. Now, like I said, you only really need 2 points after you establish your horizontal asymptote. We said our horizontal asymptote is at -3. Okay, so I'm going to draw my horizontal line at -3. And I know I will not cross it. Now my points that I have are, we have -1 and -2. And we have 0 up 5. So our graph is going to look like this. Maybe I should touch the points I just drew, right? I can't do this. There we go. I have touched all the points of my line. And we know what kind of shape it has, so 2 points is enough. Reflections of the parent function f of x equals b to the x. The function f of x equals -b to the x reflects the parent function f of x equals b to the x over the x-axis. So if you see a negative, that's a reflection over the x-axis. The changes are, your y-intercept is now 0, -1. Your range is from 0, -infinity, because your graph is now going this way. So it's going on to the negatives forever. Your horizontal asymptote, it's y equals 0 unless there's a shift. Now, what if our exponent is a negative? The function f of x equals b to the -x. It reflects the parent function about the y-axis. So we have our x-axis and our y-axis. So our graph, instead of going this way, will now go this way. It also has a y-intercept at 0, 1, and a horizontal asymptote at y equals 0. A range from 0 to infinity and a domain of negative infinity to infinity. Let's do this problem. Graph f of x equals negative 1/4 x. So I kind of don't really need much. I know it's going to be I know that because of the negative, we're going to have a reflection over the x-axis. And that's about it. So I have my exponential function, and I still have my horizontal asymptote at 0. But now, instead of going this usual way with that point 0, 1 going this way, it will now go 0, negative 1 this way. Now, I know that's kind of a lot to take in. You're like, where did she get this from? What's going on? Well, we're just using some basics, right, of how a function looks like. Now, if you want to give me a more precise graph, which is really what I want, then we would go ahead and maybe test some points. So we can do something like, you can try numbers like, we know what 0 is, maybe in n1. So negative 1/2 or 1/4 to the 0 power, that gives us negative 1. And negative 1/4 to the 1 power, that gives us negative 1/4. So we can give you a value here at 1, 1 and 1/4. So it would be over here. A good thing we did this because our graph is going the wrong way. It should be going this way. You see, that's why you always need 2 points. Because you know it's an L, but which way is your L going? Okay, just a quick summary of all the translations you worked with. Translations of the parent function f of x equals b to the x power. So you can have horizontal and vertical shifts. Your exponent is your horizontal shift, and your number that's being added to the side is your vertical type of shift. Depending, if you have a number in the beginning that's bigger than 1, you have a stretch. And if not, you have a compression, meaning it can be skinnier or it can be made wider. If you have a negative in the front, it's a reflection over the x-axis. Instead of going this way, it'll go this way. And if you have a negative in the exponent, it creates a reflection over the y-axis. So instead of going this way, it'll now go this way. And there you have your general equation. So let's do one more example using our shifts above. Write an equation of the function described below. Give a horizontal asymptote, the domain, and the range. F of x equals e to the x. It's vertically stretched by a factor of 2, reflected over the y-axis, and then shifted up 4 units. So shifted up is probably my favorite. I know at the end I will have a plus 4. Now reflection over the y-axis, that means I have a negative exponent. So I would have e to the negative x, since that is my base. Then it's vertically stretched by a factor of 2. So that means I'm going to start with the number 2. Now we're going to use this as our guide. So I have f of x is equal to e. Now I have my start at 2. I have a negative exponent, and I'm shifted up 4 units. There we have it. We built it using all of those descriptors given. Okay, that was section 4.2, graphs of exponential functions. Your homework is numbers 27 through 37 odd. Thanks.